In 2009, if your budget for a power amplifier was $4,000 or about $5,800 today, one of the options was this First Watt J2 Class A FET power amplifier. It weighs in at 25 pounds and was rated at 30 watts per channel into 8 ohms at not more than 0.025% THD, and if you lowered that to 4 ohms, it was rated at 14 watts per channel with the same THD specification, and that was at 1 kilohertz. It listed a frequency response of +0 to -1 dB from 4 hertz to 100 kilohertz. It was designed by the audio engineering legend Nelson Pass. His name is across the front, obviously. What I'm going to do is give a little tour. There's not really much going on around front, a little bit more around back, then I'll pop the cover, we'll look inside, and like most of my videos, there will be a bunch of data, and then of course I'll tell you what it sounded like and what it was to use.
This obviously is the front of the First Watt J2, and you can see that it is by Nelson Pass. The only thing interesting are two LEDs that let you know both channels are powered on. This would be the rear of the First Watt J2, of course. You can see we have our gold-plated three-way binding post. We have gold-plated RCA unbalanced inputs, or you can use the XLR balanced inputs, and they do have a jumper on them, so if you want to use the RCA unbalanced inputs, then that jumper would be in place. Power on-off switch, a user replaceable slow blow fuse, and then we have our AC power cord connection. This obviously is the inside of the J2. You can see things are pretty nicely laid out. We do have our power FETs here and the driver board for them. You can see we have two separate power supplies here and here. We even have two separate bridge rectifiers, and so there would be two separate independent windings inside this toroidal transformer. It appears there's some sort of adjustment here for either DC offset or bias. Right now I've got the First Watt J2 amplifier turned on, and it's putting out 1 watt into 8 ohm loads. It's been on for about 30 seconds, and I kind of just wanted to see how things changed as it warmed up, the THD and the SNRs, and you can kind of just look at the spectrum here. We've got our 1 kilohertz fundamental right here, and then we've got this looks to be a power supply kind of thing. Some of these are power supply, and we'll just see if it changes at all. I'll come back in about 10 minutes and then I'll recapture the waveform and see if any of this has changed. In particular, I'm curious if the THD plus noise has improved as it's warmed up, because it is Class A. Maybe it takes a little bit of warm up. I've now had the First Watt J2 on for an hour, just still putting out about 1 watt into 8 ohms, and the heat sinks temperatures are between 120 to 130 degrees F. They're warm. You can still keep your hand on there for as long as you want, but they're warm. And nothing really changed much, but there is a specification for distortion at 1 watt with a kilohertz in, and that is 0.025%, and we're basically there. This guy's 0.023%, and here we're at 0.029%. So it's basically at the level of distortion that it should be, and the input sensitivity is supposedly 280 millivolts, and we're taking about 313 millivolts to get the 1 watt. So it's off a little bit there. Here we have the First Watt J2 putting out about 5 watts into 8 ohms at 1 kilohertz. And the specification for THD, well, that was at 1 watt, is 0.025%, and we're under that for the right channel, and for the left channel we're a little bit over that, but I'm not going to worry about 0.05% THD. That's pretty good. You can see the difference in SNRs. The left channel looks pretty good. The right channel, it's not so good. You can kind of see some of the noise here, which is bringing that SNR down for the right channel. Our gain is 20 dB, the spec is 20 dB, so we're right there. I think that's a little bit lower gain that I've seen on power amps, but that's what the specification says it should be. Here is the First Watt J2 putting out about 5 watts into 4 ohm loads this time. And if you compare it with the 8 ohm load 5 watt case, the THD is not nearly as good. We're around 0.04 to 0.02%, and here we're at about 0.2%. Gain still at 19 dB, and the SNRs are about the same as they were in the 5 watt 8 ohm case. Here we have the first watt J2 putting out, we'll call it 26, 27 watts into 8 ohm loads, and you can see the gain still 19, a little bit over 19 dB. The specification is that into 8 ohm loads it should be able to deliver 30 watts at 1% THD at 1 kilohertz, and we're at 1 kilohertz, and we're right around 1%. I can tell you I can get up to maybe 27 watts before our THD exceeds that. So it's off a little bit on the THD. SNRs are 78 to 80 dB, and the THD plus noise is not very good at minus 40 dB. Now, in case you're wondering about what the harmonics look like, let's bring those up. And you can see here's our second or even harmonic, and it is lower than the third or odd harmonic. Sometimes FET designs, those are different, but with this particular unit, the odd harmonics are predominant. With 4 ohm loads connected, with a 1 kilohertz signal applied, we should be able to reach 15 watts with a 1% THD. Right now we're at 1% THD, and we're at, we'll call it 14 watts. You can see our THD plus noise is not very good, minus 40 dB. SNR, at least for the left channel, 90 dB is pretty good, but the right channel is at 80 dB, which isn't that bad. We're still showing 19 dB a gain, which is a dB less than the spec, but not too far off that. So this guy isn't going to quite hit its requirement. And let me pull up the harmonics in case you're wondering what those may look like. And here are the harmonics, and you can see that the odd harmonic and even harmonic are almost the same. Maybe the even harmonic is just a tad bigger, but for the most part, I would call them pretty much the same. Here is the frequency response from 10 hertz to 45 kilohertz, with the first watt J2 putting out about 5 watts into 8 ohm loads. The specification is that it should be down not more than a dB between 4 hertz and 100 kilohertz. I'm not going that low nor that high in frequency, but we can see that we're down at, it's basically flat pretty much at the high end of the band over here at 20 kilohertz. It's down maybe 1/10 of a dB, and at 45 kilohertz, I guess you start seeing some noise there, but even then it's 0.3 of a dB. So overall, the frequency response looks pretty good. Here we have the first watt J2's frequency response from 10 hertz to 45 kilohertz, with it putting out about 5 watts into 4 ohm loads this time. And if you compare it to the 8 ohm load case, it definitely looks like it prefers the 8 ohm load case. The channel separation was better with the 8 ohm case, although this is maybe 1/10 of a dB, so it's not really a big deal. At the high end of the band, at 45 kilohertz, we're down a dB or so. With the 8 ohm load case, we were down maybe 0.3 of a dB. And at the low end of the band, it looks like the 4 ohm case is a little bit better down here at 10 hertz, where we're maybe down 1/10 of a dB for the left channel, and before it was 0.15 dB into 8 ohm loads. And you also have more noise into the 4 ohm loads. Here is the first watt J2's output impedance from 20 hertz to 20 kilohertz, and if you translate that to a damping factor, it goes between 0.17 to 18. The specification for the damping factor is 20, so it's pretty darn close to the specification. Here is the first watt J2's crosstalk from 20 hertz to 20 kilohertz, with the active channel putting out about 5 watts into 8 ohms. There is no specification for the crosstalk, it's just kind of for reference. At a kilohertz, you're at about 42 dB for the left to right, and the right to left is about 20 dB better at 63 dB or so. So that's kind of what the crosstalk looks like. And I should point out that for all the measurements thus far, I have been using the unbalanced inputs. Here we have the first watt J2's multitone response with a minus 12 dBV signal applied. The loads are 8 ohm loads, and this equates to a distortion-free range between about 10 to 13 bits. Here is the system noise level of the first watt J2. In this case, I've got the unbalanced inputs terminated into shorts, and we're just looking at the noise of the system from 20 hertz to 20 kilohertz. The specification is that over that range it should be 100 microvolts or better, and we're not too far off. 95 microvolts for the right channel and 138 for the left channel. My guess is right around here, this 60 hertz probably will be heard when it's hooked up to the Wilson Watt 3 Puppy 2s, but it might be low enough that I don't hear any kind of hum or hiss there, but that is the system noise level. Here is the first watt J2's IMD response with 19 and 20 kilohertz tones applied, such that we're getting about 5 watts into 8 ohm loads. And this equates to about, we'll say that it's minus 60 here, and we've got 2 spurs right here on either side of the 19 and 20 kilohertz. So you would get a 1 kilohertz spur on either side, and they're down, we'll say minus 60 dBr relative to the fundamentals here, and that would give us a distortion-free range of about 10 bits. Here's how the first watt J2's THD versus output power varies, and this is done just at 1 kilohertz into 8 ohm loads. It shows that our THD is under 0.3% right here at a bit over 20 watts, and by the time we hit 30 watts, we're almost 5% THD, it looks like. And I'm using the first watt J2's balanced inputs, and I've got it set up so that with a 1 kilohertz signal, we're getting about 1 watt into 8 ohms. And there is a specification that the THD should be better than 0.025%, and we're pretty close to that, 0.03%, I guess I would call it. I'm not going to worry so much about that. Our SNRs are at least 86 dB, and you can see the gain is about 25.5 dB. Now, the specifications that I see must be for the unbalanced input, where it says we should have 20 dB of gain, and when you go to the balanced input, we get about another 6 dB of gain or so, maybe not quite 6. The input sensitivity for the balanced input isn't given, and we are hitting 1 watt output with about 100 and we'll call it 57 millivolt input. Right now I'm using the first watt J2's balanced inputs, and it definitely makes an improvement. We're putting out about 5 watts into 8 ohm loads. You can see that the gain has gone up about 5-6 dB, which is kind of what you would expect when you go to the balanced input. THDs are both at we'll call it 0.07%. We have SNRs are much better than they were with the unbalanced inputs. We'll call this 92 dB and 96 dB. So SNRs look really good. THD plus noise still is not stellar, but it's better than it was in the unbalanced input case. Here we have the frequency response from 10 hertz to 45 kilohertz, and this is with the first watt J2 putting out about 5 watts into 8 ohms, but I'm using the balanced inputs. If you compare it to the unbalanced input, it actually looks a little worse at the very high end here at 45 kilohertz. We're down, maybe 0.7 of a dB, and before we were only down about 0.3 of a dB for the left channel, and the channel balance looks a little bit better with the unbalanced inputs for whatever reason. However, it still looks pretty good here at 20 hertz to 20 kilohertz. You're within plus or minus 0.2 of a dB worst case. So pretty good frequency response using either the balanced or unbalanced inputs. Here we have the first watt J2 putting out 27 to 28 watts into 8 ohm loads using the balanced inputs in this case. The THD is at, we'll call it 1% for the most part. SNRs are better than 78 dB. And you can see our gain is 25.5 dB, we'll call it. Now, the specification once again for the rated power should be 30 watts into 8 ohms at 1% THD at 1 kilohertz. So we're not there. And in case you were wondering what the harmonics look like, here they are. There's more of a difference in the third or odd harmonic is higher than the even or second harmonic in this case with the balanced inputs. Here is the crosstalk using the first watt J2's balanced inputs, and the active channel is putting out 5 watts into 8 ohms. There is no specification for it, but it looks much better than the unbalanced inputs with a minimum of 70 dB of isolation between the channels. Right now we're looking at the rise time of the first watt J2, and our input signal is a 1 kilohertz square wave, and this is our output signal, and it's going into an 8 ohm load. There is no specification for the rise time, and this guy's measuring 1.53, which is actually pretty good. And this just shows another view of the same signal. You can see we do have a little bit of undershoot here. And at 10 kilohertz, you can see that our rise time is a little worse, 1.52. It's still one of the fastest rise times I've measured on an amplifier, and that's at a little over 10 kilohertz. And at 20 kilohertz, the rise time is showing 1.5 microseconds, so it's still pretty respectable. And this kind of just shows what it looks like at 20 kilohertz. We're seeing a little bit more undershoot and overshoot, but it's still pretty fast. And this plot shows the difference in phase between the input and the output signal, and it's showing very little phase difference at 1 kilohertz. And when we go to 100 hertz, there is very little difference in phase between the input and output signal. And at 10 kilohertz, we also have very little difference. This is, I don't know, 5 degrees or something like that between the input and the output signals. And at 1 kilohertz, there is really no difference in phase between the left and right channels. There are no specifications for any of these. They're kind of just here for your enjoyment.
I do have a big correction to make regarding the output powers, and the 30 watts per channel into 8 ohms at 1 kilohertz, the maximum THD was 1% at that power level. And for the 4 ohm loads, it was 15 watts at 1% THD. The 0.025% THD that I listed was actually for it putting out 1 watt into 8 ohms. And as you saw from the test data, it met the 1 watt requirement. It came pretty close to the 8 ohm limits and the 4 ohm limits. It was off by a watt or two on both those levels, and that was using the unbalanced inputs. Now, the test data also showed that it works better using the balanced inputs, which is usually the case. The gain went up by 6 dB. One caveat is that you would need a preamplifier that can put out enough voltage to drive this guy to its maximum. Probably most preamps will do that, but yours may not. So if you were to buy a $4,000 power amplifier, you're probably going to be using balanced outputs from a preamplifier. So maybe that's not really a problem. But for my listening test, I did connect it to the unbalanced Carver C1 preamplifier outputs, and I connected the first watt J2 to my Wilson Watt 3 Puppy 2 loudspeakers. And the first thing I always do is terminate the 2 unbalanced inputs, in this case into shorts, and I listen for any pops or hisses or hums or that kind of thing, and there was none. It's a perfectly quiet amplifier, and there were no pops or thumps when it was turned on or off, so that was pretty good. And for the most part, it just sounded like, to me, a normal power amplifier. The only area that I ran into problem was when I started to push it, probably a bit above 30 watts. I'm guessing I didn't have my little APM 100 power meter hooked up, but just kind of based on the sound levels I was getting, which was around, upper 80 dBs, maybe 90 dB at the max for the SPLs. You could hear it starting to distort, and that is what it is, but it's kind of loud at that point, and you know, if you were to have this amplifier, a Class A amplifier, only 30 watts, you probably want a horn speaker or a very, very efficient speaker to use with it. But other than that, you know, it gets warm just sitting here. It doesn't get like hot where you can't touch it, but it certainly is warm that in the summertime here in the Arizona desert, it probably wouldn't be my amplifier of choice if I had it near an area that I was sitting by, and you know, it does get warm and you notice it, but you know, it's not something you can never touch. You know, other than that, you know, it has a nice look to it, I think, and you know, if you're a Nelson Pass fan, I'm sure you would like it. To me, it looks like it would be easy to work on should it ever need servicing. And the other neat thing I thought was reading the owner's manual. It was written by Nelson Pass, I'm guessing. He says if those little jacks in the back on the XLR connectors are missing, you know, write me and I will send you one. He's very descriptive on his theory of operation and that, so I think it's a real nice owner's manual. So that's kind of my little take on the Nelson Pass First Watt J2 power amplifier. Once again, I love to hear your comments, and if you have not subscribed to the channel, please do so. Please give me a thumbs up if you thought the video was worthwhile. And until next time, have a great day or night.